Hello, everyone. I would like to go over Chapter 1, Introduction to Data. So in this chapter, we have like about 5 sections. And our objective, our goal is you will understand what does it mean statistics, how to identify categorical data and numerical data, and some example about that. So for section 1.1, so what are you learned for in this section? Actually, in more general, because you are taking statistics class, your question might be, what is the statistics, right? So statistics is the art in science of collecting, right? You imagine you're collecting and analyzing all the observations to learn about ourselves, our surroundings, and our universe. Okay, you're collecting data, you're analyzing data, and then you draw out a conclusion about that data. Okay, so the idea we can see in statistics with 5 patterns, and then so for patterns, it can helping us to make decisions, because the pattern just keep repeating, right? So helping us to get more accurate results. We all communicate the convincing argument, right? So like some argument need like proof, need something make you believe, right? And generate your result, and so that we can learn new things. Okay, we have 2 major concepts in stat. The first one we call variation. Variations in stat is have like maybe they can use more than one word to describe it. Let me annotate. Let me paint. Let me draw on it. So I may use let's see, green color. So let's see how green look like. Okay, so it's okay, right? Okay. So for variations, I can describe as like picture like this. 2 person, can stand apart, right? Or that 2 person may make a girl stuff can stand together. Right, so they're talking about like apart or together, so that the variations like far away or close next to each other. And data can be described as word or number. It can be described as, let's say, your height, okay, your weight, maybe your height, your weight, or maybe like it can be let me see, your score, maybe your grade. It can be your size of shoe size. And this can be more, it's everything around you. Okay. Okay, so next, data are recorded observation within a certain context. Okay. So you can see that I list out data are number in context, right? Like I say, can be numbers, can be a wording like I just described to you. So data are building blocks of statistics. We begin by introducing basic type of data. So then explaining how to collect data, how to store it, how to organize it, and how to analyze and summarize it, right? So both visually and numerically in the context of our real world. An example I can give it to you here is talking about, I just give you a set of number, a set of data. Okay. So this set number, you can imagine like by different story, right? Some people might think, okay, this set number can describing, let's say, the weight of the newborns, maybe, right? The weight of the newborns, or it might be your grade of your quizzes. It can be any story. But if they throw you this data, you can thinking of, okay, this can represent, you know, this and that. So right here, I can show you two examples. Can be newborn weight. Okay, newborn weight. It can be let me see. I just said your grade of quizzes, your quiz grade, your quiz grade. You can think of more of this. So what question could we answer using this data? Okay. What is the best? Okay. You know, what is the best or what is the average weight of newborn that you can think of? Because I'm talking about newborn weight right here. You can think of what is the average weight for newborn. You can think of that way, right? Question mark. For your quiz grade, you can thinking of because for quizzes usually most of teacher give you 10 points. You can asking, you can say, what is the best? What is the best grade? What is the best grade in class? The best grade in this class, in this like assignment. Okay, so you can ask any question. Doesn't have to be like me, but you can ask any question relate to that topic that you're thinking of. So next, I did mention about this part, right? So that part actually we're talking about data analysis, right? So for data analysis is another key keywords, key terms or vocab that you need to understand. So data analysis involves asking good questions. Second, we are considering the data, right? We're thinking of like which data that is good for you to, you know, get more, furthermore to investigate things. Number three, if you're interested in that data, you will sit down and analyze that data, right? You're analyzing the data by, for example, you're creating summaries of the data. And number four, so after you're analyzing it, you will interpreting it. For example, explaining what the summaries tell us about the real world, something like that. And so these are the process for data analysis, right? And again, if you have any question, please don't hesitate to email me or let me know. Section 1.2, we're talking about classifying and storing data. Okay, classifying, now we are learn how many type of data that we are focusing. So first, I would like to introduce you the vocab variables. Okay. So this variables here is not similar in math class like X, Y, or Z, something like that. So this variables here can describe as the characteristic of people or things. Okay. The variables are the characteristic of people or things. For example, if I'm interested in something about people, for example, you can see example A. What are some variables, characteristic of people that I, thinking of? You can think of the weight, right? Eye color, hair color, or gender, or any more, right? So I list out the example. I just talking about hair color, right? Hair color. Eye color, right? What else? You can think of more. Can be IQ, right? People IQ and more. You name it. So the differences between statistics and algebra that I just give you some example for variable in algebra. Can be X, Y, Z, right? The unknown number. But in statistics, variable, you need to remember it will be the characteristic of people or things. Okay. So let's give some example for the characteristic of cars. For car, what do you think of? Can think of the speed of the car, right? The type of the car. Speed or the type. Like you driving a Toyota Corolla, or you driving what else? Lexus or something like that, right? You name it. Or maybe model. And so on. There's more. And the variability of variables are called this because they have variability. So now I did mention you the variability we have just studied in section 1.1. How far away or how close of the data to each other. They are different. They are different from one person or objects to the next. Okay, that's another way. That's another way to describing the variability. Let's see. I think that's good for this section. For in section 1.2, you also need to learn about sample and population. You need to identify this. Between sample and population, population is more bigger compared to sample. Okay, so sample they will take from from a group of people from the population to make that become a sample. So I have these two boxes here for you. Sample, that's mean we call the data set, or sample is the collection of data, or I can say it's a small group from the population. The idea of this is sample means data is just part of a bigger picture. Or I can say a small group from population, period. Okay. And population, what does it mean? Population is a bigger picture or bigger group, like a huge group that represent entire entire population that researcher interested in study. The idea of the population is the data set of everything containing all the information about everyone or everything we are studying, right? And the example that I can give it to you is like this. For example, I'm talking about, I would like to study about this big group. Like, let's say I have this big circle represent for the entire population, right? And the sample will be the smaller group from that population. So this is small box here is sample. And this big circle here is a population. So our goal for population is really what we want to learn about. Okay, so we learn about the population by studying the data from our sample. That is all the time. This all the time happen in statistics, in any research, because we do not have a lot of time to study for the entire the whole population. So that's why we were choosing a group, a smaller group from the population. We call that sample. That then we're focusing on studying that sample. You can, like a researcher can pick like 1 sample, 2 sample, 3 sample, 4 sample, and so on. But they never can study like the whole thing. So that's why they will study from many samples or many small groups to study and then determine for the entire population. So I have this example here. Like I just give you an example. You can read more here. Context is the key. So I wrote here, context is a key. So what is it? So we should understand the context of a data set because is helping us to understand more what researchers are studying about, and so that we can draw out the conclusion from it, right? So there's some question that I want you to thinking of. First, what are the objects of interest? Okay, we all the time asking. Every time that you read the story, you asking, what do they interested in studying? What are the variables or will measure? And you already learn the variables, right? The characteristic of people or things. And we also question like how were they measured and what are the units of the measurement and so on. There's more, right? So depend on the question that you will see, then those questions will help you to figure out the answers. I have this example. I have part A and part B. Let me do part A, you do part B, and then example 2, the same thing, okay? You need to do the practice problem and submit to me. You need to fill it in and complete this notes and submit to me for a grade. Okay, so let's do example 1, part A. So let's identify the sample, populations, variable, and the type of the variable. Okay. So for the type of the variable, I would like to go back here. Let me see if I mention any type of the variable. Okay. So I will say more about the type of the variables below here, okay? We have 2 types of variable. The first type we call categorical or categorical. And the second type we call numerical. Categorical, an example for this will be something like, let me see, the zip code. Okay. Zip code, like we are having different zip code or the area, right? So the zip code represent for categorical because it's represent for like many people. In this case, then it will be represent for like many area, right? Each area have different zip code. It's not like measurement. Oh, that's the word. That's better. So categorical data is not talking about measurement, right? Even categorical can represent for like zip code can be a number, right? But it be listed in categorical because it's not measure. It's not like a measurement. You cannot measure the zip code, correct? Another example for categorical I can thinking of, it would be a type of something, right? Maybe a type of the flower or type of pets that you have. Type of pets. Because you cannot measure, right? You cannot measure the type of something, like pets or so that will be categorical. Let me give you another one. Let me see. Letter grade, right? Your letter grade. Right? You go A, B, C, D, right? You name it. You give me one more, if you can. Give me one more. For numerical will be opposite meaning with categorical. Is we're talking about something like we can measure. Okay? An example for this will be your weight, right? You can weight yourself. You see a number. Your height, your weight, can be a volume, right? You can measure like volume of water, volume of something. Let's see what else. Can be a number of number of cars. You can count, right? Number of car that you own. So for numerical data, it looks like you can measure, you can count. So those are numerical. And then you give me one more example here anywhere. Okay, so let's go back to the example here. So we're talking about a survey of 8,778 business executives found that 45% of them would not hire someone with a typographic error on their applications. So in this case, the sample that I was thinking of would be a number that they provided, which is 8,778 business executive. Okay, and the population I will say will be all of them, will be all of the business executives that they interested in that area. And the variable will be, I may say, because the variable will be the characteristic of people or things, right? So here we're talking about people. So I would say whether or not a business executive hires someone with typo, right? Because so the in the story they have, let me highlight it. So in the story they have something like this. So this will be the characteristic of the story. So I will put that as the variables. Okay, I will highlight yellow that. So let me write it down for you. So sample, like I said, should be this 8,778 right here, right? So you fill it in right here for me. You write it down. So that would be the sample. That is the group, is a small group of the entire population. So the population would be all of, are we using the word all? business executive. Okay. And the variable that I just highlight in yellow, so you write it down for me, please. So I save time. That's why I would like you to do it like that. For the type of the variable, you learn two types of variable. We got numerical or categorical. Right? So for this case, for you looking at the characteristic that we have, right? They're talking about something whether or not, right? So whether or not a business executive hire someone with a typographic error on the applications, right? So for the type, because they not talking about something like they can measure or count. So this I would decide to be categorical. Variable type. Okay, so now your turn to do part B. Okay, try part B, please. And the way that I'm grading your work is based on your understanding. You do right, you got more part than you do wrong, right? So try to think carefully. You can discuss with your classmate about this exercise or the exercise in class like this, in a lecture like this. Please, you can do with your friends. You can contact with your friends. You can do together with this stuff, but not on quizzes or midterms or final exams. Okay. So let me demonstrate example 2. It's similar but different topic. So let me choose part A, and then you do part B for me, please. So they talking about what here? The Hawaii Department of Tropical Agriculture is conducting a study of ready to harvest pineapples in an experimental field. They randomly choose 40 pineapples to weigh. Right, so it look like they're using what is the hint right here for you. So that will be something that would be the sample, right? Just like the sample is just like they given you a number, and then they want to because they study. Let me highlight it here. So they study ready to harvest pineapple, right? In all the experimental field. So sample would be 40 pineapple. Okay. To weigh, right? Or 40 pineapple ready to harvest. So the population would be all of it. So all ready to harvest pineapple. The variables. So the variable, what do they study? So let's read one more time. So the Hawaii Department of Tropical Agriculture is conducting a study of ready to harvest pineapple in an experimental field. They randomly choose 40 pineapple to weight. Okay, I see the word. So the variable will be the weight of that, the characteristic of the pineapple, right? So we the weight of a ready to harvest pineapple. Right? The type here, the type we have categorical and numerical. So categorical is something that you cannot count, right? But the weight here the weight here, that's represent for something that you can measure, and that will be represent for numerical. Yeah, hope it makes sense to everyone. Please practice part B, please. Types of the variable. So we got numerical, we just mentioned, and categorical. So numerical variable describe the quantities of the objects, right? That I just give you some example. Data value will be numbers that measure something, sometimes called quantitative variable. So now I would like you to do this exercise, please. You give me at least one example about numerical, and give me at least one example for categorical in this box, okay? So for categorical, like I said, we do not measure, right? Another word for that would be qualitative, but you don't have to memorize things. You only need to understand and identify a categorical variable, and you need to understand how to identify numerical variable for me. Okay, so recall variables are people, okay, and determine which variable are numerical or categorical. Okay, so talking about people, right? People here. So for numerical about people, I can talking about like the age, the weight, their height, and so on, you name it. For categorical, I can thinking of let me see, their job, right? Can be the jobs, the career, the jobs. It can be you know, their ice cream favorite, something like that. Ice cream favorite. Okay. It can be something not related to measurement. Okay? It can be the type of music, right? The hair color, right? Hair color. And so on. There's more of that. And for example B, please, now your turn to do part B for me, please. We're talking about cars. Now you need to identify for me numerical data for the car and categorical for the car. At least one, okay? Give me at least one. Okay. So for this one, I erased it. So coding categorical data. So now let's learn about coding. So for coding, we're having 1 for yes and 0 for no, or 1 for true or 0 for false, something like that. That's coding. Coding, they will convert from wording into a number, okay, or the opposite. So for standard categorization labels, we have 1 for yes or 0 for no. And coding uses numbers to indicate what category the individual is in. Coding helps both humans and computers. It's make it, when we're looking at it, we can spot out easier and make things easier, compute faster. So the word yes means nothing to the computers. So using number 1 is meaningful to the human and computer. So for human and computer, they usually add up the ones to see how many they got 2 or they guess something like that. Okay, so when computer or human, they're gonna do coding, they make it short like that, and after that they storing the data, right? So the idea is how data is recorded and stored is very important. So the way they store the data we call stack or unstack. So stack data or unstack data, and how does it look like? So for stack data, you can see the example below. The example for stack data, they usually like making the data like in column, you know, they put in columns, and they will usually having like something like this example 3 below here, I can tell you. So for stack and unstack data, for stack data, they for each row represent a person or object of interest. Okay, and each column represent for a variable. That's the characteristic of that object or person. For unstack usually has each column represent for a variable from different group. Okay, so I do not know what do you like, but usually people in stat people, they depend on you know, the situation or data, they use stack or unstack data. It depends. So for the example, I can describe over here for you to see clearer. Okay, to see what, you know, picture represent for stack or what's represent for unstack. So based on the definitions, we have for stack, with each row represent a person or objects of interest, right? And column represent for variable. So each row, look at picture number 1. We have 2 pictures. Number 1, you see each row represent for row. That mean like 7 male, 68 male, 71 male. That's how we read in by row, right? So represent per person or object of interest. Look like male got 70 inches, and so on. Like female we got 59 inches, something like that. And the column represent for the variable, right? The variable about this we call height, right? The measurement, the characteristic of the person. So and unstack has each column represent for the variable. Okay, so look like based on the definition that I have, I choose this will be stack. Stack data. Okay, for unstack, like you can see that each column, right? Each column represent for the variable. So we're talking about height. Each column, right? The variable height for men and height for women separately. So this is unstack. Does it make sense? Section 1.4, organizing categorical data. Okay, so now we're just focusing on categorical data. For organizing the categorical data, we're using two-way table. Two-way table, and we call frequency. Frequency, that means the number of repeating. Number of time or number repeating number of times repeating. Something. Okay. The idea is organizing data help us see patterns. So for two-way table, organize categorical data variables and show how many times each combination all categories occur. An example that I can show you is down here, example 1. So two-way table talking about gender and seatbelt practices. And you can notice that for men, you say 1, 1, 1, 1, 1, that represents for what? That's for yes, right? 1 for yes and 0 for no. So 1, 1, 1, that means man, yes, that's man, and 0 represents for female. So this one, number 1 represents for man, and 0 represents for women. Right? All the 0 represent for women. And similarly for the column seatbelt, 1, that means yes. And 0, that means no. Okay? So based on this, and when we run computers, they will add up for us. But here will compute by hand, so we might add up by ourselves. So let me see. So let's ignore this line. Okay, let's ignore that one because we don't see clearly. So we have two-way table that, excuse me for the computer stuff here. So two-way table will be this table. Let me box that for you to see it. See that? So that is our two-way table. So let's count. Let's count how many men do we have. 1, 2, 3, 4, 5, 6. Okay, 6 men. Wear seatbelt. So 6 men here. Wear seatbelt or not? How many wear seatbelt? So I have 6 men. How many wear it? So I have 1, 2, 3, 4. Right? 4 wearing it. So I have total 6 men. 4 wear seatbelt. And 2. So let me see how many in total. So total of men will be 6. So will be 2 right here. So female, let me count how many female we have. 1, 2, 3, 4, 5, 6. Oh, 6 too. So female, we have total 6. Let's see how many seatbelt. Female have 1. Right, 1, 2, wear seatbelt. 3, right, 3 wear seatbelt. So that means another 3 not wearing seatbelt. The total you can count is total will be 12 people. So total we have seatbelt, even men or women, total is 7. So let me write in red. Right? And we have, let's count, let's add horizontally, we have men, 2 men not wearing seatbelt and 3 women not wearing seatbelt would be 5 right here. Right? So now you can see in total, 7 plus 5 is 12. Right? And you check the total horizontally, we got 6 plus 6 is 12. So we are adding correctly. So number 12 here, that represents for the total of people that join in this study. Okay, that means we study 6 men and 6 women in this case. And we also checking if they wear seatbelt or not. Okay, so let's move on to next one. If on your side, when you see the problem, like more of the numbers, you need to react. But if you have similar slide with what I'm having, and you can copy what I have right here, okay? Because sometimes the computer, when I paste, it's not completely show up. So I only see this, so that's why I just add up to this. Okay, so first use the raw data to fill in a two-way table, which is we did, right? So now I would go over to answer this question. from A to J. Wow, that's a lot. So I might need some help from you. I will do half and you do half. Okay. So I will do part A. You will help me do, let me see that similar problem that I will do it and I split out to you. Question A asking how many people were sampled in this case. Okay. So read carefully. Okay. So how many people were sampled? Right. In this case, we have 12. Right. So 12 people. So they're not asking about probability, right? So they're asking how many, and we just saying whole number is 12. And part B, they're asking how many men in the sample, and you know it will be 6, right? We got 6 men and 6 women. Part C, how many people always wear seatbelt? How many you see wear all? Here they're talking about people. That means include men and women. And how many? 7. I see 7. Then you write 7. Part D asking how many female. Now they just asking about female. Do not always wear seatbelt, right? So now please, I believe you can do it. Part E, they talk of the sample or man. So now they're asking for percent. Percent is the fact in, you can write in, I'll show you now. I show you slowly in this case. So what percent of the sample are men? So men, we count how many? 6, right? Because they're asking for percent. They're not asking for how many anymore. So I would take the total of men, which is 6, divided by the total of the people in this study. So that means would be 6 divided 12. So 6 divided 12 look like 1/2, right? So I'm converting into percent. So 1/2, I'm using calculator. I have 0.5. And in order to convert to percent, I will take this 0.5, multiply with 100%. So when you do so, you use calculator, you got 0.5 times 100, right? Give you 50. Now the notation percent, you need to write it in. The answer will be 50%. So this is the way that you need to answer into percent. Okay, so please think that carefully and do it. Don't do it too fast. You might do wrong. So now part F, what percent of the sample? They're talking about the sample now. What percent of the sample wear seatbelt? They want you to find percent of the people, doesn't matter, men or women, but they do care about wear seatbelt or not. So now we're going to check. So wear seatbelt will be where? Yeah. Right? This slide. So wear seatbelt total is 7. Right? Remember, for total that they study wearing seatbelt and not wearing seatbelt, correct? So now, but they want us to focusing on the percentage of people wearing seatbelt. They don't care about men or women, but they do care about if they wear seatbelt or not. Then we do see number 7, right? So that would be 7 out of how many? The total of the people, the total of wear seatbelt and not wear seatbelt together is 12. So you will divide by 12. So now your turn to help me convert this fraction into a percent, like I do. Part G, what percent of the sample are females? Now they're asking for percent again, but they're talking about female who do not always wear seatbelt, right? Now we need to focus on the female do not wear seatbelt, right? So now let's go back. The percent of female not wearing seatbelt, what do you see? So let me clear. Let me clear this. I clear this so that you can see better. Okay. I will using, let me highlight it. So female not wearing seatbelt. And you see, female in this column. Go down. Not wearing seatbelt in this column or this way, right? So you see that when I draw like that, where do they cut? They cut right here. They cut right here, right this box, number 3 right here, that box, correct? So now you're going to take that box number divided by the total of the female, which is 6. So 3 divided by 6 for that case. Let's go down. So people do not wearing seatbelt here. That's the characteristic. You got 3. You found 3, right? And you divided by the total of the female. The total of female here, they're talking about female wearing seatbelt and female not wearing seatbelt. But we're just focusing on the female not wearing seatbelt only, which is 3 out of 6. So this convert to 1/2. And please help me convert to percent. When you convert to percent, please follow part E. So now on a circle, part F, part G, convert that percentage for me. Okay, so please do all circles, all the red circle that the part that I make. Part H, what percent of men do not always wear seatbelt? So this is similar case, right? So that's similar case. Now they're talking about men who do not wear seatbelt. Okay. So I would like you to try H because that's similar to part G, right? And you need to understand to do that part. Part I, what percent of women do not always wear seatbelt? So what percent of women do not always wear seatbelt? Okay, so for that question, do you think that's similar to part G? Similar way of asking? So right here, they having, again, instead of female, they're using the word women, right? So do not always wear seatbelt. Kind of similar, right? So what do you think? So you think about that one for me, please. Right? So please take a minute, think about that one. You think that's the same way of asking or different way of asking? Please try that one. Part J, who is more likely to not always wear seatbelt, men or women? So in order to do this, you need to solve for part G and part E right here. Part G and H right there in order to answer it. So which percentage is bigger? That's represent for they more likely to wear seatbelt. That group will be more likely to wear seatbelt. Okay. But right here, they want you to use information from part H and I because G, so that would be the answer. I already gave you the answer. So G and I will be similar, okay? Will be similar way of asking. So anyway, you can follow this, compare H and I for me. So it looks like you already got answer for I. So the answer would be I was similar to G. Okay, so please do it. Rewrite it. So let, for example, two, that another way of doing it, or another way of finding percentage or asking how many by using not two-way table, but by writing. So this example two, what do you say? A recent study of 400 students found that 65% carry calculators. Okay, of those trying calculators, 40% were male. Okay, so when we analyze this carefully. So we're having 400 students. This 400 students include male and female. plus male. Okay. And they found that 65% carry calculator, that this 65% that represent for female and male who carry the calculators. Okay. And this but they given us 40% were male. Of those, okay, of those carrying calculators, which is this 65% of the people carrying, including male or female, we found that 40% of them are male were carrying the calculators. And now they're asking how many students were carrying the calculators, right? How many? So when they asking you how many, that means they want to know a number, the whole number, right? So they're not talking about percent in here. So they're talking about a number. So in order to know from 65% here, right? Because 65% carry calculators here, that's percent. They want to know a numbers, okay? The whole numbers. In order to figure it out, what do I do is I would take 65%. Figure that out. So I got 400 of student. I multiply with 65% to get that number of the student. And in order to do, I put it in my calculator. I have to convert 65% into decimal. So I have 400 multiply with 0.65. So 0.65 is decimal form. 65% is the percentage form. They are both equal. But in order for you to plug in a calculator, you need to convert into decimal and compute it. And when you compute it, I have 260 students who carry calculators. Right. So you can check with your calculator for me. Part B, how many non-male students were carrying a calculators? Non-males here, right? They're not male, right? And then they're asking how many. That's mean they're asking for a numbers. So based on, because you read this, of those carrying calculators, which means we have 260 people carrying calculators, and 40% were male. 40% of 260 were female, were male. So now we calculate non-male. In order to find non-male, what do we do? So let's compute. We're going to take. There's more than one way of solving this. So what I'm going to do is I will compute on number of male first, and then I will take 260, take away number of male to get number of non-male. Okay, so let's do that way. So I will convert. I will take 260 multiply with 40, which is 0.4. I got my calculators. I have 104. This is male. Male carry calculators. Right? So now in order to find non-male, I'm going to take 260, take away 104. And I have 156. This will be non-male carry calculator. Okay, so my answer is 156. Okay. So if you have another way, so please show it or share with your friends. You actually you can thinking of like 260 student carry calculators represent for 100 and 40% were male. So of course 60% would be female, right? So you can take 60% time with 260 to get 156. It's the same thing. It's the same way. Okay, so example 3. So maybe I let you do example 3 for by yourself or with your friends, because this example is similar to what I have just done. Example 2. Okay, so you do example 3, please. Think carefully. Okay, that's similar. So based on this, similar, and let me read over part B to see is it similar to what we have. It looks like it. A large law firm is made up 65% male lawyers or 169. It looks like they given you already, like they already converted 65% into 169 already. So they're asking for what is the total numbers of lawyers at the firm. So I believe you can do this one. Okay, by applying the method, we need to find the total. Like, let me give you a formula for this one. Let me go up here to give you a formula for what I have done. So I can say, so this is the formula will be total you time with percent, right? And you got amount of subgroup. So this is a formula that you need to apply for this type of problem. So go down here, example 3. Part B is look like they given you percent, they already given you amount in subgroup, right? So this is the formula. Okay, this is the formula. I just give it to you. They asking for a total. They're asking for a total right now. So you have to represent for total as X and then solve it by using algebra. Okay. So next, part C, you're using the same formula again. It's look like you have total, you have the amount of subgroup. They're asking you for percent, right? So now percent will be the question mark or X value that you need to solve. Apply the same formula, okay? But please plug it in and solve algebra. 1.5, causality. Causality, in this section, you're learning about collecting data to understand causality. What does it mean, causality? Many important questions are ones about causality, or another word, cause and effect. Which ask question like, what if? What if I do this? Will this happen? Something like that. And this can be understood in terms of two variables. So you don't need to really like memorize this variable. So you only need to like understand how to apply intersection. For the way that they write treatment variable here, they're talking about treatment, okay? And they're talking about the outcome or response variable. So this is not like categorical or numerical at all. This is something else. This is a definition for treatment or the outcome or response variable. We identified that based on these definitions. So the goal is to see if the treatment variable causes change in the outcome variable. Right? This is our goal. So to answer question about causality, we will consider two groups. We call treatment group and we call control group. Okay, for treatment group is the group that receive the treatment of interest. Right? Receive treatment. Treatment group, that the group that receive treatment. Or have the characteristic of interest. Okay, for the control or comparison group, the group that does not receive the treatment of interest or doesn't have the characteristic of the interest. So, okay, let's try this. Okay. So for this one, so does drinking red wine decrease the chance of heart disease? That's the question, right? Okay. So researchers followed 800 red wine drinkers and 900 non-red wine drinkers for 5 years, then measure the rate of heart disease. So part A question, what cause and effects we are looking for in this case? Please take a minute, think about this. So it looks like we are considered like, is it true that we drink red wine can help us decrease the heart disease? So that might have cause and effect, right? In this case. So my writing would be something like, if a person drink red wine, then, right? Then a person, the chance to get the heart disease will be decreased, huh? Period. Okay. So cause is drink red wine, right? Effect will be the chance of the heart disease will decreases. B, what is the treatment variables in this case? The treatment variable, like we mentioned, is carry the characteristic of interest, right? So we do interest in talking about drink red wine will decrease the heart disease, right? So you can looking at the question, does drinking red wine decrease the chance of heart disease, right? So that mostly that would be the interest, right? So I will say whether or not a person drink red wine, right? Or not a person drink red wine, but that's a treatment variable. So we are interested talking about the person drink red wine. What is the outcome? The outcome will be something talking about decrease disease or not, right? That look like the results. We go back here. Yes. Doesn't have the characteristic. Okay, so I'm going to say rate of heart disease. The treatment group is what? So let's go back to the definition so that you can see it. That's the group that's received treatment of interest. Right? So we have found that 800 red wine drinker will be the treatment group.